Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem from LeetCode Biweekly contest question 3, that is maximum total value of covered indices. Let's read the problem. You are given an integer array nums of length n and a binary string s of length n, where si is equal to 1 means index I initially contains a token and si is equal to 0 means it doesn't. You may perform the following operation any number of times. You may or you may not. There is your choice. Either you want to perform this operation or you not want to perform this operation. So what is this operation? Choose a token currently located at index I where I greater than 0 such that this token has not been moved before. What does it mean? One token can move one time only. If the token is already moved, so you are not allowed to move that token again. So you only allowed to move that token which is not moved before. Move this token from index I to I minus 1. Since I is greater than 0, so there is always I minus 1 present for a I. So move this token to I minus 1. An index is considered covered if it contains a token after all moves. So what is the covered meaning? Let's discuss it. What is the meaning of covered? Let's see. Initially there is an array like this A B C D and initially D and B has token. So what are the possible ways in which the token are distributed? It might be possible that this D will transform its token to C. So the new state will be this type. And in this case the covered indices is here after all moves. It might be possible that B transfer its token to A. So the new state of this array is like this. So in this case, the covered indices are A and D. So these two indices contain the token after all moves. Then it might be possible that this D transfer its token to C and this B transfer its token to A. So the new case will be this, where A has a token and C has a token. So these two indices are covered after all moves. Then it might be possible that B remain its token in its place and D remain its token in its place, doesn't transfer its token to I minus 1. So the new state will be remain as it is, and in this case the covered token is this. So I hope you know now what is the covered indices means. Return an integer denoting the maximum total value of nums at the covered indices after optimally performing the operation. So as you can see, in this case the covered indices is B and C, so the total value is B plus C. In this case the covered indices A and D, so total value is A and D, A plus D. In this case the covered indices is A and C, so total value is A and C. In this case, the covered indices is B and D, so total value is B and D. So out of all those possibilities where the token is present at last after all moves, you will consider the sum of the nums array, that is your total, and you have to return the maximum out of all possibilities. So I hope you understand the question and know what the question asking by from you. So let's discuss its approach now. There are two approaches for this problem. There are two approaches for this problem. The first one is greedy and the second one is DP. I will discuss both of them in this video, but before that please hit the like and subscribe button because I consistently make such kind of intuitive video for you. Let's discuss the greedy method. For illustration of this greedy method, we will consider the nums array this type 24, 3, 5, 2 and 100, and the corresponding string for this nums array is 0, 0, 1, 1, 1. Let's analyze the operations in this string and analyze what is the optimal way of operation. If you carefully see, initially this is the state of this array. Initially 2 has token, 5 has token and 3 has token. So what are the possible transition for this array? It might be possible the token will remain at its position and no transfer is done. So then the new state of your array will be 3, 5 and 2, and in this case the total will be 3, 5, 3 plus 5 plus 2. It might be possible that 3 transfer its token to 24 and 5 doesn't and 2 doesn't. Then the new state will be 100, 24, 3, 5 and 2. In this case the total will be 24 plus 5 plus 2. Then it might be possible that 2 transfer its token to 5 and 5 transfer its token to 3 and 3 transfer its token to 24. So 2 has not any token at last. So the new state can be 100, 24, 3, 5, 2, and 2 doesn't have token but 5 has token, 3 has token and 24 has token. So in this case the sum is 24 plus 3 plus 5. The other case can be like this: 5 transfer its token to 3, 3 transfer its token to 24. So now the 24 has token, 3 has token, but 5 has not token because 5 transfer its token to 3 and 2 has token. So in this case the total value is 24 plus 3 plus 2. It can easily seen that this 100 will not contain, this 100 can't contain token after all moves, because there is only one move allowed for a token, and in one move token can go to the I minus 1 only, not I minus 2. So this 100, it will never happen that this 100 can get a token from this set of tokens initially. So this 100 cannot add to our total. So this is our total number of possibilities that can be happen from this state. So there are only these four candidates which can have token at last, and out of these four only one candidate doesn't have token at last. Like in this case, if you see 3, 5 and 2 has token but 24 has not. So 24 is excluded. In this case, if you see 24, 5 and 2 has token but 3 has not. So 3 is excluded in this case. In this case, 2 is excluded because 2 has not token after all moves, and in this case 5 is excluded because 5 has not token after all moves. So my question to you, which element you want to exclude from your total sum? If you think greedily. So if you think greedily, you always want to remove the minimum element from the array. So we want to remove the minimum element out of all possible candidates, because it will give you the, it will maximizes your total sum, because it will maximizes your total sum. So out of these candidates 24, 3, 2 and 5, like in this window 24, 3, 2 and 5, which element you consider to exclude? You consider this element to remove. remove this element because it is minimum. So after removing it, your total sum will be simply 24 plus 3 and 5. It will give you the optimal total sum, which is maximum. So I hope you understand why you remove the minimum element out of all those candidates. In this question, there is an edge case also. What happen if there is no zero before the consecutive ones? So the case is, what happen if there is no zero before the consecutive ones? So in that case, the candidate are simply these candidates. Like in this case, it might be possible that this string will give to you for this array like 3, 2 and 5. So in that case, all of them has a token 3 to 5 and there is no 0 present before, so there is no any element before where the candidate has not a token. So if you consider this case, the optimal answer will come simply 3 plus 2 plus 5. So in this case, there is only token size candidates. In this case, there are only token size candidates. There are three tokens and there are only three candidates. In this case, there are three tokens but there are four candidates because it is not having any token and the corresponding character for this string is 0. That's why there are four candidates in this. But if there is no there is an starting token, the string starts from 1, so there is only token size candidates for a total sum. So in this case, you don't need to remove anything. In this case, you don't need to remove anything. So uh, as you do this say as you do this step for a small test case like 0111, so you can do this to big test case also, like if the string is 011 011 001 and 011, so you only consider the consecutive block of ones, and if there is a 0 present before, so the candidate is x plus 1. So out of those x plus 1, you will remove the minimum one and get your final optimal answer, because for each block of 1 you maximizes your answer. So after doing the same step again and again, you will maximize the global answer. Do the step for each block of consecutive 1 to get the global optimal answer. I hope you got this. Now let's discuss the code for the same approach. This is my Java code where I initialize my answer. This answer stores the final answer. Final answer is stored in this answer variable. N is the h dot length, string length, and we traverse the string character by character. If that character is 1, so there is a chances of consecutive blocks. So first of all, you will check whether this I greater than 0. So it will specify you whether there are x plus 1 candidates or not. X plus 1 candidates or x candidates. If I is greater than 0, so there are x plus 1 candidates. What is the x? X is number of consecutive ones. So if I is greater than 0, so there are x plus 1 candidates, so you have to remove the minimum one. And if I is greater than 0, then flag will become true. So if flag is true, then you will remove the minimum one, otherwise you don't need to remove anything. You will add all of them, all of the elements into your answer. First of all, you will add all of the elements into your answer while I is less than n and s dot caret I is equal to 1. It means that it process the block of consecutive ones. So after processing this previous element and the block of consecutive ones, you will remove minimum only in that case if there is flag is equal to true. Otherwise you don't need to remove anything from your answer. Similarly, you will return your final answer, and the return type should be long. Please keep it in mind because the return type for this function is long. I hope you understand my code and the intuition behind this problem. Please hit the like and subscribe button because I consistently make such kind of intuitive video for you. Now this is the case of greedy approach. Let's discuss the DP approach also. If you carefully see, there are only two choices. There are only two choices available at that index where the token is present. So I hope you got this. What are these two choices? So first choice is move the token towards left, means I minus 1, and the second choice is keep the token with you. So you can easily do it with DP approach. It is like a house robber problem, the standard DP problem, where there are two choices. In this case also, move the token towards left, that is I minus 1, or keep the token with you. If you keep the token with you, like the case is left, in the left case, you will add nums of id minus 1 and will call the previous index memo of I minus 1, because this will add it to you because you go to the left. And in case of same, when you remain at the same index, then you simply add nums of id to memo of I minus 1. Why I distinguish this I and id? Let's discuss it also. Since there are only two choices available at that index where the token is present, so first of all you have to store those indices where the token is present. So you have to do this DP approach on updated list. We have to do this DP approach on updated list. What is the updated list? Updated list contains list of all indices which is having token initially. Like in this case, let's say the string is like this 011 010 01. So in this case, if you find your updated list, the updated list will simply, let's indexing it 0 1 2 3 4 5 6 7. So updated list is simply list of indices which has token initially. So this indices in this index 1 has token, index 2 has token, index 4 has token, and index 7 has token. So this is our updated list which contains the list of indices where the where the token is present initially. And at every index you have choices whether you want to uh, take your left or you want to remain at the same index. There is a two choices. You want to remove your token, you want to transfer your token to left I minus 1, or you want to transfer your you want to take your token as it is. Let's say for 7 there are two choices. If you take left, so where you go, what you will do, you will add nums 7 minus 1 to your answer, because 7 minus 1 is 6. So you will add 6 to your answer and call your memo for I minus 1. If you indexing it 0, 1, 2, 3, so the new index will be 2. So I hope you know now what is I and what is ID. I is the index of updated list and ID is the index of original nums. So how can you find ID? You just simply do list dot get of I. It will simply give you ID. But there is an edge case in this approach. Let's say you have an array 3 and 2 and both of them has token. So what you will do, there are two choices at this. So you can do 3, go to left, and you will reach at the index 0 because you are initially at index 1. So go to left and plus 3, and if you remain as it is, then you will increment plus 2 because same will do the nums of id same as plus memo of I minus 1. So if you do I minus 1, you will reach at 0. In this case also you have two choices. Either you remain as it is. If you remain same, so you will go to minus 1, because memo of I minus 1 will be result you minus 1, and you add plus 3. And if you do minus 1, because it is nums id is 0, so you can't go to minus 1, so here the left is not possible. In this case also there is no left possible, left not possible, but there is a possibility of same call. So if you call same, then it will increase plus 3 to your answer. So out of this, if you find the answer is 6 according to your this approach, nums of id minus 1. So out of this, you will return the maximum of left comma same, maximum of left comma same to get the optimal answer of your total operations, total sum of your nums array. So in this case, the answer will store 6. If you carefully see, is it possible to get answer 6, because there are only two tokens, and in the best case both of the candidates can add. So in best case 3 plus 2 is the possible answer, so 5 should be the correct answer. But why it is giving 6? Because when you go to the left, you will when you go to the left, then you take this 3 two times. But if you consider the covered indices in this method, in this path, the covered indices, if this 2 give its token to 3, so 3 has now token, and 3 has its own token also. So covered indices is only 3, not 2. So in this case you should return 3. So In this case you should return 3 because you don't mark it as the same doesn't call for this call. That's why same will call its nums id plus memo of I minus 1. That's why 3 plus 3 will give you 6. But in this case you have to mark it such that the same will not call for this left. So the observation is for this problem is, if there are two consecutive ones, there is a conflict between left and same, because you add you add nums of id minus 1 two times, which is incorrect. So you have to do a track whether you call same for that left or not. So there is an extra parameter in memo also. So we have to use an extra parameter in memo, that is 0 or 1. What is the 0 signifies? 0 signifies that we can call same, and 1 signifies we can't call same for current id. I hope you got this. Like in this case, since it is a consecutive ones, one is here and one is here also for 3 and 2. So when you call your left, and the left will give you 3 plus nums of 3 plus memo of 0. So you add additional things in this, that is 1. That will denote that you are not allowed to take you are not allowed to call same in this case. Like if you mark it 1 memo 0 comma 1 0 comma 1, then this call will never happen. This call will never happen, and it will result you the correct answer. So I will discuss this same thing in my code also. Let's jump to the code now. Here is my simple Java code with memoization. Let's make it white. I make the nums array and the list of indices and the DP as globally, so that I will take the minimum parameters in my memo function, because I always prefer those parameters in memo function which are changing. So in this case, what I will do, whenever s.character I is equal to 1, I will store that index into my list, and this will give my updated list. And after that there is a dp array of new long, which is containing the size of list dot size, and column size is 2. First column is used for first column is used for element, and second column is used for check, that is whether we have to call same or not. So in this case also I simply do the same. Firstly I initialize my left as long and integer dot min value. List dot get id is equal to is greater than 0 means you can call your left. So left will be nums list dot get id minus 1. Initially left is integer dot min value. If it doesn't happen, then after doing this math dot max left will be discarded. But if it is possible, then left will be initialized to nums list dot get id minus 1. Whenever there is a consecutive ones, this check is using this will check whether there is a consecutive ones are present or not. So if it is 0, it means there is no consecutive one, no consecutive one, and if it is 1, there is a consecutive one. So I hope you got this. I explained this in my dry run of the test case, edge case also. So you can easily find this. So you will call your same, you will initialize your same to integer dot min value, and if it is possible to take, if it is possible to call same, because check is equal to 0, it means then you can call same, then you call this function memo id minus 1. You will do this statement, otherwise you will not do this statement and the same will be discarded because it is integer dot min value, and after this call same will be discarded if it is if doesn't update in this statement. So simply you will do mat.max of left comma same, just like a standard DP approach with memoization. I hope you understand my code and the intuition behind this code, and how this code handles the edge cases of double adding of the same element nums id minus 1. That's why we use 0 and 1 for tracking of whether we have to call same function or not. That's why we got the correct answer, and it will generate all of the possibilities and find the optimal total value of the nums. In this way, we can easily do this question with DP approach also. I hope you understand my code and the intuition behind this problem. Please hit the like and subscribe button because I consistently make such kind of intuitive video for you. Thank you.